Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, welcome to the Industrial Talk Podcast. You know my name is Scott McKenzie, and we're broadcasting from IoT Solutions World Congress from the beautiful town of Barcelona, Spain. And it's not a town, it's a thriving metropolis. And we're brought to you by Industrial Internet Consortium. Go out to iiconsortium.org. Don't miss out on that org part. And if you have any interest whatsoever in, let's say, AI, IoT, IIoT, security, everything you want to know about it, that is your number one stop. That's Industrial Internet Consortium, and it's iiconsortium.org. They're great people. They're passionate about your success in this world of Industrial 4.0. Okay, we've got a great interview. He's going to be great. He has a unique sporting passion, but we're not going to talk about it because I can't talk about it. His name is Alex. It's Alexander, but Alex. Don't help me, Alex.
I'm not going to.
No, you're not.
No.
Smolensky or Smolensk.
Yeah.
Did I do
good,
it? I got
good.
the. I
That was one
I
good,
did,
yeah.
right?
Good.
Yeah. And he's with Zyfra. He is head of AI. So we're just rocking and rolling here. So how you doing?
Oh, wow. Great. The Congress is great. People are great. There are some beers around, so quite
Are there
good.
beers around? Where do you see beer?
Oh, you have to look for the big consultancy firms. Not much to offer, but beer is great.
It's true.
Sorry
true.
for offense.
And it is getting a little late in the afternoon, so people are talking about beer, talking about all that good stuff.
Oh, yeah.
So for the listeners out there, Alex, give us a little background on who you are, where you come from, and then we're going to talk a little bit about Zyfra.
Okay, great. So, me personally, I'm from IT. I've been probably on all steps of IT. I was a systems administrator, software developer, and a head of software developers. And then I worked for IBM as a systems architect and for big consultancy firms like KPMG.
Oh.
And I'm in AI for the past, I would say, 4 years, driving the innovation. Sorry for this.
No.
Swear words.
There's no. You're doing a great job.
No, yeah.
You're too sensitive about you. You're rocking it.
Well, I mean,
He's got a lot of passion. Everybody, you got to look at him. I mean, I'm being sucked into his passion. It's all good.
there is a running joke in AI community. If you say AI, it's PowerPoint. If you say it's ML, it's real stuff. So we're doing ML. Yeah, machine learning.
It's machine learning.
Yeah.
Ladies and gentlemen, that is called AI Trash Talk. Trash Talk AI. No kidding.
Yeah.
So are you in the machine learning business or the AI business?
To be frank with you, and I cannot be frank with a man. Yes.
On your material, it says AI. So
We do both. We have to do both. That's the market right now.
okay, so you're out of Helsinki.
Oh, yeah.
By the way, I had a wonderful opportunity to attend a bar at the top of this particular building. Have you been there? It's the tall one, and it has a spiral staircase to get up to the top of the bar.
Oh yeah. I know the location. I mean, it's more of a tourist spot. So,
Oh, wow.
Yeah, but it's great. It's great.
It is. I just thought it was a health hazard. After you
Uh-huh.
get done drinking, you got to go down the spiral stairs.
Oh yeah. So you have to
Gotta be
calculate your
careful.
strength, Yeah.
I love Finlandia. All right, that's a shout out to my passion. All right, let's talk a little bit about Zyfra and what you're doing from a machine learning. See how I did that?
Yeah.
Machine
That's
learning
great,
perspective,
yeah.
because you guys are real and you guys are coming up with tangible results associated with your technology and how you're increasing yield and all that good stuff. Let's talk a little bit about what you guys are doing.
Okay, yeah. So Zyfra is not your typical AI startup. We are, I would say, not only AI company. We are doing end-to-end manufacturing automation, and we excel at mining, at metallurgy, at oil and gas, chemicals and petrochemicals, and machinery. There are like 5 sectors that we are covering, and I mean, we're not small. We are like around 700 people. Right. And for each of this sector, or for each of these niche that we're covering, we have AI solution. And I would say we're a little bit different from the rest of the pack because we are not trying to do, one of a kind project. We are not trying to, sell some kind of a platform. We are doing very specific things that are very close to actual equipment, actual industry, and we are all about business effect and replicating our solutions, our ML models, our neural networks on specific equipment all around the world.
See, that's interesting from that you're pushing for lack of a better term, a standardization associated with the deployment of your solution. And I think that has a significant industrial appeal. So when you go out to company A, you say, here it is. Plug and play to a certain extent. I'm not trying to simplify it, but there is and when you say end to end, what do you mean by that?
Well, I mean, let's say mining. Well, it's a simple example.
Yeah, because it's right here.
Mining. So what do we have here? We can actually right now we can do autonomous mine for you. Absolutely, you fence the territory, and there will be no people at all. If you want to visit us in Casablanca, Africa, or you want to go to northern Kazakhstan or southern Russia, you will find mines where there is no people at all. It's a fenced territory, and everything run by certain solutions, AI, and so on and so on.
Okay, so let's talk a little bit about that. So you got autonomous solutions for mining, and that means machinery that's doing all of the whatever mining does mining.
Let me correct you here. I mean, we got the capabilities. The reality here is semi-autonomous mining. Because, okay.
Good, I gotcha. Yeah, but there will be a point when it's autonomous. 100%. It just is.
Yes, definitely. But I wouldn't be expecting too much in the coming short to mid-term. Yeah. I would say autonomous mining will come in, 10 to 15 years.
Yeah.
And not because technology is not ready. Technology is ready.
It's ready. It's the human element. It's the
human
person.
element. The government relationship.
Government. I was going to relate. There's a regulatory component. The human, and being able to define that type of business model, relationship, and the impact it might have.
Yes, and if I can move with the mind a little bit further, so let's say you have autonomous or semi-autonomous transport. It doesn't mean that it stops there. What we do, for example, for mines in AI, we do granulometry. Granulometry is, what is mine? You put in explosive, you blast, and then you sweep with excavators and trucks what falls on the ground, and then you repeat the process. That's a typical mine. And to control the blast, to calculate the blast, you need a very precise information about the
geotechnical characteristics of that particular area.
And right now, what's happening in most of the mines in the world, a person from the blast team, demolition team, comes down to the mine and makes 4 or 5 photos. And what we did computer vision for this, and we go from 1 to 2,000 photos for each blast. And not only photos, we calculate every granule that we can get our hands on, and we get very precise information to the blast team.
But don't you, do you have the technology to be able to go in subterranean and say, okay, so I'm going to blast here, and it has this sort of geotechnical characteristic, and if I do it this way, I optimize the yield from that particular...
Actually, we have very, very similar technology, but not for mining, for oil drilling, actually. Why?
Yeah.
Because it makes economical sense to do it in oil drilling, because the cost of drilling, And in mining, it's actually cheaper to just drill and explode and to see the results and base your next explosion on the previous one. So it makes more economic sense.
Oh, interesting. I didn't know that. That's interesting. But I see the benefit associated when we start talking about oil and gas, because you mentioned briefly that increasing a yield 2% on a specific platform is through that ability to look at the the quality and the just sort of the characteristics of that particular.
Well, I mean, that's it's a point of pride with us because it's really a very interesting and very unexpected result. There is an oil well, and obviously there is an oil pump, there are compressors, there are watering pumps, and so on and so on.
Yeah.
And usually it's a balance between how much water you want to push underground without watering the well, and how much oil will be pushed back to your tube, to your pipe.
Right.
So when we tried on a single well, we achieved some like miraculous results, like 12-15% of more oil output.
Greater yield?
Yeah,
Oh,
yeah.
God.
I mean, and we didn't believe it.
That's a significant improvement.
It's not real. But then, I mean, we understood. Our petro engineers didn't believe it as well. We understood that oil wells are obviously connected, and so if you push hard on one of the wells, the others will actually lower the yield. And that's why we understood that we have to move through all the ridge at once. So we have to control all the wells in one area, and there we can control. So it's not a single pump, single watering compressor.
They're related to it in some way. I mean, it's just you can't help because you're hitting that. I'm thinking water. That's an aquifer, but you're hitting that stratum, whatever it might be.
There are aquatic lanes actually there sometimes. So and that's why you cannot do like a single AI solution. You have to control each well individually and also control all the wells at once. And if you do that, you can actually still achieve, I would say, wonderful results. I mean, 2% yield in terms of sheer oil and money, it's enormous.
It's enormous.
And it's actually, it's not tampering with the ecology. It's not adding to any, harmful natural. Yeah. So it's just you're just getting more from the same oil well.
You're providing some sort of additional pressure within that specific area that's impacting these wells that are all sort of interconnected, and saying, okay. You
see,
can do that.
the trick here is like you have different regimes of the equipment, and they are usually controlled manually right now. There are there are standards, there are intervals, and oil engineers would just look at the manual and put the standard modes. But when you are controlled, and a human being cannot control this many oil pumps, for example, at once, where there can be dozens and dozens of oil wells. So where AI is significantly better than human, it can react better, faster, and it can push the equipment to the limit, but not exceeding the safe interval. And that's where you get your additional pressure, your additional oil without risking of, for example, watering the well and destroying it. Right. And that's where you get additional, you get business.
The yield, it's get greater yield. I just, what fascinates me, you're absolutely right. Through the use of, let's say, AI, machine learning, whatever you want to call it, you have that capability, and not to diminish the ability of a person. Don't get me wrong.
Oh, no.
But the ability to be able to process more rapidly and see that data and say, good data, bad data, and have that ability to be able to learn from that. That's what we're talking about. Humans can't do that.
Actually, another own guest story, if you humor me for a minute.
I humor you for another 3 minutes.
Okay, yeah, that's more than I deserve, definitely. But anyway, we did this interesting project which we're rolling out, and it's bitumen production. I actually gave a presentation at this... Did
you say bitumen?
Bitumen.
Bitumen,
yeah. Bitumen is a crude oil.
It's a crude oil,
yeah.
I stored it.
Yeah. I mean, you use it for roads, for waterproofing,
Did a lot
and
of
it's not. And it's not like. I mean, you do not use bitumen you find in measure. You cook polymer modified bitumen.
Yeah.
And so what we did, we made an AI ML system. Where we can because when you cook bitumen, you add in elastomer, plastomer, and then spices like sulfur, tar, and all the add-ins amount to like 75% of the cost, and bitumen costs only 25%. So, by the same logic, we actually were managed to reduce the median cost of bitumen batch by 3.5%. And we actually managed not to only roll out it once, but on several bitumen production plants. So, I mean, if you would like, for example, you would roll out it on most of the bitumen plants in the world, not only you will save a significant amount of money, but also you will save some dangerous and harmful components for the environment, like sulfur, because sulfur is actually poison, and you don't want it to be near the manufacturer more than is absolutely necessary.
Yeah, no, you're absolutely right. I just, so this is all great. Where's your biggest challenge?
Biggest
the human element.
Oh no! Actually, that's why I wanted to mention in bitumen. Like we do the recipes for the batches, but still in every plant, bitumen engineer uses only 70% of our recipes. 30% he is usually inventing himself because
what? I didn't know that.
Because I mean. Because there are some things that's outside of any AI system, like, for example, you want to save elastomer for future batches, or in your specific region, sulfur or tar costs very much money, so you want to save that. Or you have some idea that the next shipment of plastomer will be only in a month, you have to be careful with that. So there are many things that you cannot account for right now. And so the reality is that interaction between human and AI gets the best results.
Wow. I mean, you guys get it. I mean, how are you coming along with your standardization approach? I mean, I mean, that's that's a bold statement when you get right down to it, because it's not that easy sometimes.
Yes, I mean, and that's why we are trying to look for particular areas and particular tasks and particular equipment where standardization is at all possible. If you are talking about some huge thing like, I don't know, we had this presentation on the conference, increasing the NASCAR racing output something with AI.
Right.
It's cool, so cool. And, well, you probably cannot use the results anywhere else.
That's exactly right. You're not going to.
Yeah, and we are like, we are humble, simple people, far from Starbuckses of the world, and just trying to do something that is replicable.
Way to close that out, you humble, simple people that are doing AI, machine learning stuff. I'm sorry, we have to wrap it up.
Okay, thank you all.
No. There's a protocol.
Okay.
I have a standardization that I always do.
Sure.
Hey, are you out on LinkedIn?
Oh, sure I am.
Are you active on LinkedIn?
I am.
No. Your quiet partner's out there too, I would imagine.
Oh, yeah.
Okay, so guys, you need to contact this gentleman because I think he's onto something really big. His name is Alexander. That's DR at the end. Smolensky.
Cool.
Zyfra is the company. Zyfra. Find him. Link with him because you have to. Because he's looking at the world differently in a very positive way. He's solving problems. And again, thank you very much for joining the Industrial Talk Podcast. Once again, we're all from the IoT Solutions World Congress, and we are broadcasting with Industrial Internet Consortium. Go out to iiconsortium.org. Find out more. And I'm telling you, doggone it, connect with Alexander because he knows what he's talking about. Thank you guys for joining me.
Thank you so much.
You were awesome. This is a great event.
Oh, yes, it is.
No, I mean, it's wonderful. Thank you, listeners. We will be back with another great conversation with people like Alexander and company. They know what they're talking about. So stay tuned for more interviews.